Hi guys, in the previous lecture already we start unit number second in the paper second, which is application of derivative, and there we start first point of the application of derivative, which was in the geometrical part, equation of tangent and equation of normal. So already we solve the equation finding the equation of tangent and equation of normal by using, we know that if y is equals to f of x be any curve and point P x1 y1 lie on the curve which is y is equals to f of x, then we know that about if y is equals to f of x be any curve, so we can y is equals to f of x be any curve and point P which lie on the curve, the coordinate of P which is x1 y1, then passing this point, line which is passing through this point P intersect to the curve y is equals to f of x at point A, which was a tangent, and if the line is perpendicular to the tangent, it means that make angle it's 90 degree, that was normal. So now we know that the slope of tangent which is denoted by m which is a slope of tangent, and if the line is perpendicular to the tangent, then which is normal, minus 1 upon m is a slope of normal. By using this criteria, we find equation of tangent is y minus y1 is equals to m in bracket x minus x1, and equation of normal which is y minus y1 is equals to minus 1 upon m into x minus x1, which was the equation of tangent and equation of normal. By using this same process, now we have to find the examples which is given are as follows. The first example in the so here, by using the equation of tangent and equation of normal, we can find point on the curve which is given by y is equals to x cube minus 6x square plus x plus 3, and it is given that tangent is parallel to the line y is equals to x plus 5. It means that if the given line and the tangents are parallel to each other, then their slopes are equal. If it is clear that the slope of both tangent and line are equal, then we can calculate the slope of tangent by differentiating with respect to x dy by dx at given point. And here the given equation, given line which is in the form of y is equals to mx plus c, it is a slope form equation. The coefficient of x which we call as slope of the given line, hence here slope is 1, and here we can find slope of this equation. So first we take given curve y is equals to x cube minus 6x square plus x plus 3. If we differentiate with respect to x, then we get dy upon dx is equals to derivative of x cube minus 6 into derivative of x square plus a derivative of x plus a derivative of 3. We can take a separate derivative of each term in addition and subtraction form. Hence the derivative of x cube is a 3x square minus derivative of x square 2x, 2 into 6 which is a 12x, plus derivative of x which is 1 plus derivative of 3 which is 0. Hence we can say that dy upon dx is equals to 3x square minus 12x plus 1, which is a slope of the given equation. We can write equation 1. So we take tangent are parallel to the line which is y is equals to x plus 5. Comparing with slope of our equation y is equals to mx plus c, we can compare coefficient of x m, which is slope coefficient of x1. We can write m is equals to 1. Equation number 2. If line and tangent are parallel to each other, then their slope are equal. Hence, from 1 and 2, we can say that 3x square minus 12x plus 1 is equals to, which is 1. So, if we take this one left side, 3x square minus 12x minus plus 1 minus 1 is equals to 0. Plus 1 minus 1 cancel. We can write 3x square minus 12x is equals to 0. Here, if we take 3x common from both term, we can write x minus 4 is equals to 0. Here we can write therefore 3x is equals to 0 and x minus 4 is equals to also 0, and the value is the value x is equals to 0 and x is equals to 4. Here the point x is equals to 0 and x is equals to 4. Here we have to find point on the curve, the point which lie on the curve, point P, x comma y. Hence, if x is equals to 0, then we can find the value of y. If x is equals to 4, then we also can find the value of y. Y is equals to given that when value we put in equation 1 or in this equation which is 0, then we can write 0 minus 6 into 0 square, which is 0, plus 0 plus 3. So here 0 minus 0 plus 0, we can write value of y, which is 3. Then point P, x1 y1 represented by x0 y3. So again, if x is equals to 4, we can write y is equals to 4 cube minus 6 into 4 square plus 4 plus 3. We know that the value of 4 cube, which is 64, minus 4 square is 16. 16 into 6 is 96 plus 4 plus 3 7. 64 plus 7 71 minus 96, which is y is equals to minus 25. Hence again point P x1 y1 represented by 4 comma minus 25. Hence the required point which lie on the curve is 0 comma 3 and 4 comma minus 25, which is a required point which lie on the curve y is equals to x cube minus 6x square plus x plus 3. By using the same process to finding the equation of tangent and equation of normal, here we have to solve question number 2, which is in exercise number 2.1. In the previous lecture, we already show question number first. In this question, already we find equation of tangent and equation of normal. So also here, we have to continue that, find the point which lie on the curve, which is parallel or perpendicular to the tangent to the line. So similarly, we know that first equation of tangent which is y minus y1 is equals to m in bracket x minus x1. When the line is parallel to the tangent, then m is the slope of tangent. If the line is perpendicular to the tangent, then equation of normal we can write y minus y1 is equals to minus 1 by m into x minus x1. Here minus m means line is parallel to the tangent. Also we know that normal means normal is a perpendicular to the tangent, and hence minus 1 upon m, which is the slope of line which is perpendicular to a tangent. So similarly we can find here point on the curve y is equals to under root of x minus 3, where the tangent is perpendicular to the line 6x plus 3y minus 5 is equals to 0. Here we know that the equation of tangent y minus y1 is equals to m in bracket x minus x1. Y, x is a variable of the equation, y1, x1, which is a coordinate of point P. Similarly, equation of normal y minus y1 minus 1 upon m x minus x1, which is a coordinate of points. So, if we have to find the point which lie on the curve, then first we consider that point, let P be the x1, y1 which lie on a curve, and curve is given y is equals to under root of x minus 3. So again given that where tangent is perpendicular to the line, means we can find by using this line slope of this line in the slope form which is equals to y is equals to mx plus c. By using this slope form we can find the slope of this line which is perpendicular to the line. Here y is equals to under root of x minus 3. If we differentiate with respect to x, then we get derivative of y, which is dy by dx, is equals to under root of x minus 3, the derivative of under root x minus 3, which is 1 upon 2 under root of x minus 3, and we take again a derivative of x minus 3. So the derivative of x is 1, minus 3 is 0, 1 into 1, 1. Hence dy upon dx is equals to 1 upon 2 under root of x minus 3, which is the slope of the given line. Now again we know that tangent is perpendicular. Here tangent is perpendicular. Tangent is perpendicular to the 6x plus 3y minus 5 is equals to 0. If we convert this equation in the form of slope form equation, which is y is equals to mx plus c, then we can find the slope of line which is perpendicular to the tangent, means it gives slope of normal. So the given equation 6x plus 3y minus 5, if we take 3y, 6x right side we can write minus 6x plus 5. Now the slope form is y is equals to mx plus c. If we remove this 3, divide 3 both side, we can write 3 by 3, y is equals to minus 6 upon 3, which is 2x plus 5 by 3. Hence by comparing this y is equals to mx plus c, we can write slope of line which is perpendicular to the tangent is equals to minus 2. By using this we can find slope of line parallel to tangent, which means that m is equals to minus 1 upon minus 2. We can write it minus minus plus 1 by 2, which is number 2. Now we can say that from equation 1 and 2, we can say that slope of both line and tangent now is equal. Hence we can write 1 upon 2 under root of x minus 3 is equals to 1 by 2. So if we take this 2 under root of x minus 3 right side, 2 left side, then we can write 2 is equals to 2 under root of x minus 3. 2 to get cancelled, we can write under root of x minus 3 is equals to 1. So here taking square both sides, if we take square both sides, we can write x minus 3 is equals to 1. If we shift this minus 3 right side, we can write x is equals to 1 plus 3, hence the value of x, which is 4. If we substitute this value 4 in equation y is equals to under root of x minus 3, then we get the value of y which we required. Therefore, a become y is equals to under root of x minus 3. Here y is equals to under root of 4 minus 3. Y is equals to under root 1 means y is equals to 1. So we have to find the point which lie on the curve y is equals to under root of x minus 3, where the tangent is perpendicular to the line 6x plus 3y minus 5 is equals to 0. Then we can say that required point which lie on the curve Px1 y1 represented by x coordinate which is 4 and y coordinate which is 1. So again here question number 3 is similar to question number 2. So here we have to find the point on the curve y is equals to x cube minus 2x cube minus x, where the tangent, here tangent is given parallel to the 3x minus y plus 1 is equals to 0. It is simple that first here slope of curve and slope of tangent are same because tangent and curve are parallel to each other. When tangent and curves are parallel to each other, then their slopes are equal. Hence we can find or we can compare slope of tangent and slope of curve. So here we have to first find equation, find the point on the curve. Let P be a point x1 y1 lie on the curve y is equals to x cube minus 2x square minus x. If we have to find the slope of this curve, then we differentiate with respect to x. The derivative of y, which is the dy by dx. Here we take a derivative of x cube minus 2 into derivative of x square minus the derivative of x. The derivative of x cube, which is 3x square, minus 2 into derivative of x square, which is 2x, minus derivative of x1. We can write also it dy upon dx is equals to 3x square minus 4x minus 1, which is number 2. So the tangent is parallel to the line, which is tangent is parallel to a line, and the line is 3x minus y plus 1 is equals to 0. And then their slope form is, if we shift this minus y right side, we can write 3x plus 1 is equals to y. Hence y is equals to 3x plus 1, which is a slope form. If we compare slope form, y is equals to mx plus 1, we can write slope of tangent. It means that m is equals to, or m is equals to slope of tangent is equals to 3, number 2. Here m is slope. We know that if tangent and line are parallel, then their slope are equal. Hence from 1 and 2 we can say that 2 and 3 we can say that the equation which is 3x square minus 4x minus 1, which is the slope of this line, and the slope of parallel line which is m is equals to 3. If we shift this 3 right side, we can write 3x square minus 4x minus 4 is equals to 0. Minus 3 minus 1 we can write minus 4. Hence 3x square minus 4x minus 1 is equals to 0, which is in the quadratic form. So here we have to find the value of x. If we factorize this equation, 3 into minus 4, we can write minus 12. 6 into 2 minus 6 plus 2, we can factorize 3x square minus 6x plus 2x minus 4 is equals to 0. So here we can take common from 3x square minus 6x. 3x we can write x minus 2. If we take here plus 2 common from x minus 2 is equals to 0. X minus 2 is another common bracket we can take. Common from both, we can write x minus 2 in second bracket. 3x plus 2 is equals to 0. By comparing, first bracket x minus 2 is equals to 0 and the second bracket 3x plus 2 is equals to 0. Here x gives the 2's value, two values, which is x is equals to minus 2 become plus 2 and x is equals to minus 2 upon 3. If we take the value of, or we can write this x1 minus 2, 3x1 minus 2. If we take the value of x which is 2, then we can calculate the value of y which is in form of value of x is 2 by 3, 2 cube minus, first we write this y is equals to x cube minus 2x square minus x. And the value of x which is 2 cube minus 2 into 2 square minus 2 cube 8 minus 2 which is minus 2. Therefore point P x1 y1 represented by x2 y minus 2. So if we put x is equals to minus 3 by 2, then we can write x cube minus 2x square minus x minus 2 by 3 bracket cube minus 2 into minus 2 by 3 bracket square minus of minus 2 by 3 minus x. So here minus 2 cube which is minus 8 upon 3 cube 27 minus square of minus 2 4 into 2 which is 8 by 3, the square of 3 which is 9 minus plus 2 by 3. If we equal denominator, if we equate denominator, we can write minus 8 minus 9 into 3 27, we can write it 8 into 3 minus 24 plus 3 into 9 27, we can write 2 into 9 18. So minus 8 minus 24 we can write minus 8 plus 18 plus 10 minus 24 minus 14 upon 27. We can write point P x1 y1 represented by when x is equals to minus 2 by 3, then y is equals to minus 14 upon 27, which is a required point which lie on curve 2 comma minus 2 and minus 2 by 3 minus 14 by 27. Here the question number 4, which is find the equation of tangent to the curve, and the curve is given that x square plus y square minus 2x minus 4y plus 1 is equals to 0, and the given curve which is parallel to x-axis. It means that if the given curve is parallel to x-axis, then it is clear that slope of x-axis, which is the equation of x-axis, y is equals to 0. Hence slope of x-axis is 0. We can write here slope of x-axis, that is m is equals to 0. After that, the given curve x square plus y square minus 2x minus 4y plus 1 is equals to 0. Here we can find the slope of the given curve, which is differentiate with respect to x, derivative of x square plus derivative of y square minus 2 into again the derivative of x minus 4 into derivative of y plus derivative of 1 is equals to 0. Derivative of x square, which is 2x, plus derivative of y square, which is 2y, minus derivative of x1, 2 into 1, which is 2, minus 4 into dy upon dx, and the derivative of 1, which is constant function, is 0. Here derivative of y square, which is 2y into dy upon dx. If we take dy by dx common from both term, or we can write 2y into dy by dx minus 4 into dy by dx. If we shift this remaining term right side, 2 minus 2x. So here, if we take dy by dx common from both terms, we can write 2y minus 4 into dy upon dx is equals to 2 minus 2x. We have to find dy by dx. So here we can write dy upon dx is equals to, if we take 2 common from this term, we can write 2 into 1 minus x upon, if we take 2 common from this both term, we can write 2 into y minus 2. Here 2 get cancelled, we can write dy upon dx is equals to 1 minus x upon y minus 2, which is the slope of the given line or given curve, which is number 2. We know that here the curve is parallel to x-axis. Curve is parallel to x-axis, and we know that the slope of x-axis, which is 0. Hence we can write from 1 and 2 1 minus x upon y minus 2 is equals to 0. If we shift this y minus 2 right side, we can write 1 minus x is equals to 0 into y minus 2, which is 0. Hence the value of x, we can write x is equals to 1, or here we can write x is equals to 1. Here we have to find equation of tangent and equation of normal, or equation of tangent. We know that x is equals to 1. By using the value of this x, which is 1, we can find value of y. If we substitute this value in this equation number 2, put x is equals to 1 in 2, we can write x means 1 square plus y square as it is, minus 2 into value of x, which is 1, minus 4 into y plus 1 is equals to 0. Here 1 square means 1 plus y square minus 4y minus 2 plus 1 is equals to 0. 1 plus 1, 2, 2 minus 2, 0. We can write y square minus 4y is equals to 0. If we take y common from this both term, we can write y in bracket y minus 4 is equals to 0. Here, if we divide both sides, we can write y is equals to 0 and y minus 4 is equals to also 0. Therefore, y is equals to 4. Hence, we can say that the equation of tangent when slope is 0 or curve is parallel to x-axis, then the equation of tangent, which is y is equals to 0 and y is equals to 4, these are the required equation of tangent. Here we have to find the equation of normal. To the curve 3x square minus y square is equals to 8. Equation of normal to the curve means the given curve which is in the form of normal, it means that normal is perpendicular to the tangents. If the slope of tangent we consider m, then the slope of normal is minus 1 by m. So here are parallel to the line x plus 3y is equals to 4. By using this equation of line in form of slope form equation, we find first slope of the equation. After differentiating this curve, we can find again slope of this equation. So first, given curve, which is 3x square minus y square is equals to 8. Here, if we differentiate with respect to x, we can write the derivative 3 into derivative of x square minus derivative of y square derivative of 8. Again we can write the derivative of x square, which is 2x minus 2y into dy by dx is equals to derivative of 8, which is 0. So if we take 2y dy by dx right side, we can write 6x or 2 into 3x is equals to 2y dy by dx. So here 2 get cancelled, we can write y into dy by dx is equals to 3x. So the value of dy upon dx is equals to 3x upon y, which is a slope of tangent. But here we have to find the equation of normal. Therefore, from this we can find slope of normal. So we can say that slope of tangent, that is m is equals to 3x upon y. We know that slope of normal, which is minus 1 by m, is equals to minus y upon 3x, which is number 1. So again, the given line which is parallel to this curve, given line x plus 3y is equals to 4. Now we can write this equation in slope form. 3y is equals to minus x plus 4. If we divide 3 both side, we can write y is equals to minus x upon 3 plus 4. Hence, slope of the normal, which is minus 1 by m, is equals to minus 1 by 3, number 2. From 1 and 2 we can say that minus 1 by m minus y upon 3x is equals to minus 1 by 3. If we shift this 3 left side, we can write minus 3y upon 3x is equals to minus 1. Here 3 get cancelled. Minus y upon x is equals to minus 1, or minus y is equals to, we can write minus x, hence y is equals to x. Here we have to find the equation of normal to the curve 3x square minus y square is equals to x, which is parallel to the line x plus 3y plus is equals to 4. So the required equation, if we put the value of x, which is y, or value of y, which is x, we get equation A become 3x square minus the value of x, which is also y, or y is equals to x. Hence we can write y is equals to x square is equals to 8. 3x square minus x square, which is 2x square, is equals to 8. Hence x square is equals to 4. The value of x, which is plus or minus 2. Now we can calculate here for x is equals to minus 2 or x is equals to 2. Then by calculating this value, y is equals to 2. It means that is p x y x1 y1 represented by 2 comma 2. For x is equals to minus 2, then also y is equals to minus 2, then point P x1 y1 lies on minus 2 comma minus 2. By using this Part-2 equations, first we have to find equation of normal at a point 2 comma 2, which is y minus y1 is equals to m in bracket x minus x1. So here y minus, if we take y1 plus 2 is equals to value of m, which is slope of the normal minus 1 by 3 into x minus 2. If we take this 3 right side, we can get 3 into y minus 2 is equals to minus x minus 2. 3 into y, which is 3y minus 6 is equals to minus x plus 2. If we shift this minus x right side, we can write x plus 3y minus 6 minus 2 is equals to 0, which is x plus 3y minus 8 is equals to 0, which is the required equation of normal with point which lie on 2 comma 2. Now again we have to find equation of normal with or at minus 2 comma minus 2. We can write y minus minus 1 which equals to minus 1 by 3, or m into x minus x1, y minus of minus 2 is equals to minus 1 by 3 into x minus of minus 2. Y plus 2 is equals to minus 1 by 3 into x plus 2. If we shift this to right side, we can write 3 into y plus 2 is equals to minus x plus 2. 3y plus 6 is equals to minus x plus minus 2. If we shift this minus x and minus 2 right side, we can write x plus 3y plus 6 plus 2 is equals to 0. X plus 3y plus 8 is equals to 0, which is the required equation of normal. So the required equation of normal to the curve 3x square minus y square is equals to 8, which are parallel to the line x plus 3y is equals to 4 is first equation of normal is x plus 3y minus 8 is equals to 0, and the second equation of normal which is x plus 3y plus 8 is equals to 0. So if you like